Hey, this is Step Ahmet. Welcome to my exorcism.io series. In this video, I'll be working through the protein translation exercise from the exorcism.io Ruby track. So what we need to do here is translate RNA sequences into proteins. And the rules are, we take RNA, it can be a strand of RNA of these nucleotide sequences can be broken down into groups of 3. And a group of 3 is called a codon. And each of these translates either to a particular protein or polypeptide or to a stop sequence, a stop codon. And when we see one of these stop codons, it doesn't translate any farther. So here, all subsequent codons are ignored. So here we have AUG, UUU, UCU, UAA, and then AUG. And so as we look at these groups, we see that AUG translates to methionine, UUU translates to phenylalanine, UCU is serine, but UAA is one of these stop sequences. So even though there is UAG afterwards, which would translate to methionine again, the translation stops and it doesn't continue. That breaks the translation. That's the end of the RNA sequence. And so this is the sequence of proteins. Okay, cool. Here's a group of all these translations, and I think we'll probably need that in some sort of hash in a minute, but for now, let's just pull this down. Copy in my rake file that allows me to run my tests with my with a Vim shortcut that I've got. And I'll go ahead and remove the existing protein translation.rb file, which contains just some comments in it, and I'll start a new TMX session. Let me open up the test and see what it says. All right, so there is that protein underscore translation.rb file that will contain a class called translation with a class level method of codon, which will take a 3-character string and return the polypeptide. Okay. Okay, here on 59, we see there is also an of RNA that takes a longer strand and returns an array of polypeptides that it finds. And it has to be able to handle the stop codon. Okay, and we've got an invalid codon error that we need to raise if we don't know what we've been passed. And that looks like, so this is of RNA. Okay, cool. So let me open up my test running pane, and I'll go ahead and execute the tests. I'm always pretty strict about my TDD here and making the tests guide my workflow. I usually try to predict what the tests are going to do. Right there, I just ran it without making a guess, but I'll try to remember to make a guess as much as I can. And really, all that does is help make sure that I'm paying attention to what I'm doing. Okay, so this first error is because I deleted the file. I need to recreate it now, just as an empty file. So I'll do that, and I'm going to swap the panes here. I like to have my class under test on the left. I'll execute the test again. That error will go away, but now it's going to complain that I have not. I didn't name it. You gotta name it right. My prediction was going to be I haven't initialized the translation method, and so one of the reasons I guess is because it keeps me on my toes. So I can see things like that, like, oh, that's not the error I was expecting. It's a different error. But I'll go ahead and take care of that by renaming this file protein translation.rb. And if we were pairing, you probably would have caught that. You probably saw it as I typed it, that it was wrong. And now that is the error I was expecting. Class translation. The next error is going to be that we don't have, I don't have a class level method of codon. So I'll go ahead and create that. And rather than let the test tell me that it takes a codon, I'm going to go ahead and force it to and return methionine. And that first test will pass. I hard-coded it, but I'm not going to get away with that for very long. I'm going to have to implement the real solution now because, as you can see, I'm passing not only different codons or codons that return different polypeptides, but two different versions that return this one. Okay, so this is 3 different codons I need to be able to handle now. And so what I'm going to do is this kind of thing where I've got, I'm translating from input to a given output, and it's a sort of one-to-one like this. That's immediately makes me reach for some type of dictionary, which in Ruby, that's going to be a hash. And simply look it up and return the value from there. And so I'm going to write the code that I wish I had here. And what I would want to call this, I think, is codons to proteins. Because I think that captures it, and pass it the codon. Of course, this won't work because that doesn't exist yet, so I need to create it. So let me go ahead and create it up here. And so far, I've been given AUG, which returns methionine. I've been given UUU, which returns phenylalanine, and then UUC also returns phenylalanine. So the first 2 tests should pass now. Okay, I spelled it different. I spelled it wrong. Well, hang on. Phenylalanine. Typo. Okay, cool. So let's just keep going. Here's the next one, leucine. This is going to fail because our hash does not contain that value. Those keys are values. So let me go ahead and add them. UUA, and that returns leucine. And UUG. By the way, I have no idea if I'm pronouncing these correctly. This is just this is a guess, best guess. Also leucine. Okay, so let's test identify serine codons. Serine, I think, is probably how you say that. Of course, we don't have them at all, so let's add them. UCU. UCC, UCA, and UCG. Okay. Tyrosine. Of course, it fails because we don't have those values in our hash, so it's UAU and UAC. So let's just start with UAU returns tyrosine, and then UAC. Okay. Cytosine. No, sorry, cysteine. Cysteine, cystine. I don't know how you say that. This test is going to fail, of course, because we haven't added these yet. So UGU. Cysteine. And UGC. I'm beginning to see a pattern here with these sequences, and which ones return the same polypeptide. All right, so here tryptophan. Tryptophan, the sleepy polypeptide. This is the Thanksgiving one, which I think is a myth, but it's a persistent one. Tryptophan, okay. And, okay, the stop codons. So these should all return stop. Let's go ahead and add them here, UAA. UAG and UGA. All right, so of codon now does what it's supposed to do. And so what we need to do now is translate an RNA strand into the correct protein. And so the protein will be this sequence of polypeptides. So this is going to fail because we don't have a class level method of RNA. So we'll need to add that. And of RNA, IDC takes a strand, and I'll just go ahead and add that. And I think I'm gonna go ahead and implement this because we have of codon. Some of the work has been done here. What we need to do is we need to break this into groups of 3. And I think the way we need to do this is to first translate it into an array. Because if I have an array of the characters of the chars, I can take each slice of 3. And then let me put these here. Whoops. I can take each slice and join those slices back together. Map. And by I mean join each slice back together. So that now what I'll have is an array of 3 character strings that correspond to these codons up here. And so now what I can do is I can map this again and pass it my hash with this unary ampersand character. Because remember what unary ampersand does is it translates things to and from procs. It will call to proc on an object. And if you give it a symbol, what that's going to do is it's going to return a proc that it will pass each element. It will call join on each element here so that we wind up with our array of 3 character strings. But when you call toProc on a Ruby hash, here I'll show you the toProc method if you haven't seen this before. It returns a proc which maps keys to values. So you can call it with a key and it will return that value. And so in this case, what's going to happen, map is going to hand each element, so each codon that we have, to that proc, which will look it up in the hash and return the value. And so what we'll wind up with is we're translating this array of codons to an array of polypeptides, and that will return the protein that we want. And that'll be enough to make this test pass. Notice that I'm not dealing with stop characters yet because the tests have not asked me to. So even though that works for this simplest case, look, I see right here, test stops translation if stop codon present. It's going to fail right now. It's going to fail. And things are going to get more complicated immediately. Okay. So I really need two cases here, I think. If my array of codons contains, or let's just say this array of polypeptides at the end contains a stop codon, then I want to be able to take this array here and just go from 0 to that, so the stop index, to 1 before it. But I only want to do that in this case. So if I do this here, that's going to make everybody else fail. Every other test is going to fail. Because stop index doesn't exist. So we'll have to define that. So let's see. Man, okay, in order to make this happen, tell you what, because I want to get this thing. Let me for right now. Let me just save this raw codons, and so if I had the stop index, which I created there, stop index is going to be raw codons index of stop, right? And what I want to do is if stop index is nil, which in Ruby, if it's not found, if this isn't found in your array, then the index will be nil. So if it's nil, then I want to return raw codons as is. Actually, this isn't codons. I call it raw codons, raw polypeptides. Raw polypeptides. I want to return raw polypeptides. That's right. Yeah, if it's nil, that's what I want to do. Otherwise, I want to return raw polypeptides 0 up to stop index -1. Yep. That makes sense what I did there. I have this case where I want to return something, somehow if there's a stop codon, I just want everything up to that point. I want to stop processing after it. And I guess there's other ways I could do this, but this seems pretty clear to me to do it this way. That if I don't have one, I just want to return the array of polypeptides. If I have one, then I want everything up to but not including the stop index, and I want to ignore everything from that stop forward. Okay, so let's keep going, and then I'll refactor that in a second. Test stop translation of longer strand. Yeah, that should work. I don't know why that wouldn't work. Test invalid codons. This will fail because I'm not raising invalid codon error. So there is no such thing, first of all, as invalid codon error. So what I want to do is define it here. And I just want to inherit from argument error because it's a type of argument error. But I don't want any special functionality for it. And so with a hash, you can define default behavior. So for instance, here I can set a default of let's see, default equals let's say we wanted it to be stop. So anything else is stop. That's not what we want the default behavior to be, but you could do it this way. You can also create a new hash with the default value. And so any unknown key will return the default value that you initialize it with. But you can also do something else here. Let me get back up here to the methods default proc. So you can give it a proc that has certain behavior here. You can either do it here on hash.new, or you can set default proc to a proc with a certain behavior. And so that's what we want to do. We've explicitly set every key that we know. And so we want to set a default proc that will say, if you give me any key that I don't know, then I want to raise an invalid codon error. And I don't care about the hash. I only care about the key. Actually, I don't care about either. What I can do is, so let's see, raise invalid codon error new and give it the key. Not that we're checking it, but that's a nice way to behave so that if we were checking it, we would be able to look and see that, oh yeah, that's a key. I don't know that key. Okay, cool. So I closed the test because they're all passing now, but I want to do a little bit of refactoring here. And pretty much all here in the of RNA method. First off, I've got a magic number here for the slice size. I'm just going to call that codon length or codon size. You want to, as much as possible, you want to avoid numeric and string literals down in your code. You want to give those names and pull them out to constants so that you don't have those unnamed things just kind of all over. It's not obvious when you come back later to edit code to change it. It's not obvious usually what those things are. It's like, well, this is a number. Why is this 3? I don't know why it's 3. But if I name it codon size, and I do this in a consistent way, for instance, by using constants, well, I can go and I look at for constants up at the top of the class and go, oh, okay, yeah, codon size is defined up here, and codon size is 3. We could do the same here. Stop polypeptide. Yeah, it's a lot more characters. I'm a little ambivalent about this actually, because that string stop is pretty clear to me. But what if we change the value? Well, then I've got to change it in a bunch of places. So I don't know. So I might put it up here. Okay. This 0, it represents the beginning, the first index. This 0 and this 1 I think are fine here. Okay. So the next thing I want to do, I think, is break this up. Anywhere in side of a method where I'm setting a local variable like this, this is usually an indication to me that my method is doing too much. It's doing multiple things. And the single responsibility principle teaches us that a class or method should have one job, one job and one reason to change. Well, now this method has 3 jobs and 3 reasons to change. One is to create our raw polypeptides array. The other one is to determine the stop index if there is one. And then finally to return the protein represented by that polypeptide chain, which will either be the whole thing or just up to any stop index or any stop polypeptide. So 3 things. So at the very least, I want to break this apart. And so the easiest way to do that in Ruby is just to create a private method with the same name as that local variable. That's what I'm going to do here. Wait, this is inside of a class method. Okay, so if I keep this as a class method, I'm going to have to pass around strand and yeah, all over the place. I don't want to do that. So immediately when I get to this point where it's like this is getting more complicated, the of codon is pretty simple, right? I'm just looking up a value in a hash. But here, this tells me that I need to turn of RNA into a class level convenience method. And so these almost always look the same. A class level convenience method is almost always exactly what I'm about to type here. The code that I want is this: new strand dot of RNA with no arguments, right? Because I'm initializing a new protein object with the strand, and I can call it of RNA. And so strand will become an instance variable on my object, on my instance. And then I can take all of this stuff, take it outside of this class shovel self, and just define of RNA. I'm going to paste the contents in. So this won't work yet because strand doesn't exist. It's going to tell me strand doesn't know what strand is. Oh, no. So it's gonna fail here on new because I don't have an initialized method that takes strand. So let me do that here. Create an adder reader for strand and define initialize to take strand and then set that instance variable. All right. And so now I can start breaking this apart. I'll create some private methods here. And they're private because they're not part of the surface area of my class. They're not part of the explicit API as defined by my tests. So this was called raw polypeptides. And then stop index as well. Let me go ahead and take that out of here. Okay, and so now I can start to think about this. I can do something else. Do I want strand to be the raw string, or do I want to break it up into the codons? Also, this, do I want strand to be the array of chars? I could further, I could call this codons, because that's really what this is, right? These are the codons. I think that makes sense to strip that down. So let me just decompose this a little bit more. And actually, it's not that. It's this whole thing up to here. All right, so let me explain why I'm breaking this down the way I do. I'm going to back up here to of RNA. So of RNA now, if I look at that class level method, all it does is initialize a new protein object with the strand and call of RNA. And then that instance method checks to see whether or not there's a stop index. So how do we do that? Oh, actually, let me just read this. Let me read this method real quick. If stop index is nil, return the raw polypeptides. Otherwise, return raw polypeptides from the beginning up to, but not including the stop index. Does that make sense? See, that's clear now, kind of what that is. I'm not talking about the details about what any of these things are yet. Just that I know that when I've got my raw polypeptide chain, I'm going to return everything up to, but not including any stop index if it exists. So what is stop index? Well, again, I take my raw polypeptides and I look for the stop polypeptide and I return the index of that. So I'll either have a number that's an index of that stop polypeptide or nil. Okay, so what about raw polypeptides that I see all over the place? Well, the raw polypeptides are the codons mapped to proteins, codons to proteins. Actually, should these be proteins or should these be polypeptides? Let's rename that. So the raw polypeptides, again, we take our codons and we map them to the polypeptides using this codons to polypeptides hash. All right, so what are our codons? We were given a strand. Well, to get the codons from the strand, we get the characters, the chars from the strand. We get each slice of codon size, and we join each of those, giving us an array of codons. All right. Actually, I think that's pretty clear. Does it make sense? Is there anything else you see that you would do that might make this clearer? It clearly works. It's a lot cleaner than it was a second ago. I'm not crazy about this ternary here. Whenever I see a ternary or any kind of like if else, I always try to think of a different way of handling this that doesn't involve a branch like this. But it's not occurring to me off the top of my head. If stop index is nil, there's, I wish I could just do this. Wait, I wish I could just do this and have stop index be, either a real index or one past the end of the array or something so that this just works in both cases. But if I do that, I'm just moving that conditional, that logic here, because this is always going to return nil if it doesn't exist. And instead of nil, I want it to be the length of the array, right? Let me see if this works. But I don't want of RNA to have to know about that stop index. So I think I want to capture this here. So I like how this cleans up of RNA. So now there's only one thing happening here. There's not that ternary that I didn't want. I do the same thing in every case. I take my raw polypeptides and I go from the 0 index all the way up to the stop index. Whatever it is, that's what I return. And so stop index then, here's what I like about it. Of RNA doesn't have to make that decision. Stop index, which is named such that I would expect it to give me the final index, the last one that I want to return. So maybe not stop index, maybe it's end. Because it's not exactly the stop index anymore. It's the ending index it's the end that I want to go to. And so end index's job is to either get the index of a stop polypeptide or the length of the whole thing and subtract 1 from whatever it is. Because the length will be is 1 greater than the final index in the array. And the stop polypeptide, that index will be 1 greater than the final element I want to return. So actually, I think I like this better. Is this too clever? Is this too clever? Is this hard to understand? Does this make sense what's going on here? Let me think about this for a second. Because sometimes you're making trade-offs. The goal is not just working code, is not just efficient code. We want our code to be maintainable. I want to make sure that when somebody else comes in here that doesn't have all the context that I've got in my head right now, which is probably me in 6 months when I've got to come in and make a change. I want this to be easy. I want to be able to just kind of read this and know what's happening intuitively without having to untangle weird bits of logic and bits of cleverness that the person that wrote it thought, felt really good about, but that just make my job harder down the road. And so I feel like of RNA on line 45 is much cleaner. That's much simpler. But I move that decision point here. And instead of a ternary, I just use an or, right? Because what's going to happen is if this is nil, it's going to pass through to this side and return this. Let me read this. So end index is the raw polypeptide's index of stop polypeptide or the raw polypeptide's length minus 1. The only other thing I might do is name this bit. Like, what is this thing? But I think for now I'm going to leave it here. Even though technically this is end index is doing two things. It's making a choice about a number to pivot on, and then it's subtracting 1 from that number. The only other thing that bugs me a little bit about this is the only reason I can subtract 1 from both of these is that they both happen to be 1 greater than the last element that I want, but for completely different reasons. This one because it's the index of stop. This one because the length of the array of a zero-based array is, 1 greater than the index of the final element. I don't know. So I've got mixed feelings about this. What I think I would do at this point is probably just commit it because it's not that complex, and the complexity is shoved down here into this one method. So in the spirit of that, I'm going to go ahead and submit this. All right, awesome. Well, thanks for making it this far. If you're still watching, thanks for watching all the way to the end. And yeah, if you found this valuable, please hit the like button below. Maybe leave a comment and subscribe if you want to know when I've got more of these videos coming out or other things on this channel. And also, if you want to level up your refactoring skills so that you know how to write code today that you won't hate in 6 months, and know how to make those decisions, have a methodology for making those kind of decisions that you just saw me making, and then I'm making all these videos, then please check out my tactical refactoring course listed in the description below. All right, have a great day, and I'll see you in the next video.